And welcome back to another video where I forget to press the record button. So what is Truffle? I'm going to start all over again. What is Truffle? Let's see. So this is Truffle, but let's first go into the definition. So Truffle is basically a tool that allows you to develop smart contracts. It's an industry standard, which means everyone uses Truffle. So if you want to become a smart contract developer, you must either use Truffle. You have some other options, to be honest. You have Truffle, but Truffle is the first tool that came up, and also you have Hardhat here, and you can, if you go, you can see there are more stars on Truffle than Hardhat. And by the way, Hardhat, to be quite frank, I probably prefer Hardhat because it's newer and it's more modern and all this other stuff. But let's go back into Truffle. So Truffle is just a JavaScript package. You can install it with npm. And by the way, we will use Truffle in this video to create a project in which we'll test all the features of Truffle. We're going to develop, deploy, and test smart contracts. And also we're going to not only deploy locally on our local blockchain, but we'll also deploy on a public testnet. About the technical stuff, and by the way, I didn't show you, but this is how Truffle project looks. When we later run Truffle, you'll get this project, npm project, and you'll get a folder where you create the contracts. So you can write Solidity code here. You will develop contracts. As I said, Truffle allows you to develop the contracts here. And also we will write tests in JavaScript. And basically these are all the tools you get. Also, Truffle, very important thing, it allows you to create and deploy smart contracts on any EVM compatible blockchain, which means you can deploy this to Ethereum, to the Binance Smart Chain, etc. Also, it supports, if we go actually here, you can see it supports the Solidity programming language to write smart contracts and Viper. Nobody uses Viper, but just in case you were wondering. So also it uses Ganache as the local development blockchain, and actually I'm just going to keep this for later. And also, as I said, Truffle allows us to test the smart contracts or that we develop with this framework, which is also the framework that Truffle uses. So this is a separate, you can download this separately. It's called Mocha. It is very popular. It looks like 5.6 million weekly downloads. And let's get our hands dirty. So let's not be boring and only learn the theory like people do when they go to college. So how can you install Truffle? You can install it using npm, doing npm install -g. It stands for globally, which means you're going to install Truffle globally, so you don't have to install it later for the other projects. I already have installed this. And by the way, here I have just opened an empty folder, which reminds you to subscribe. And I'm going to initialize our project by doing Truffle init. And just like that, we have successfully created our Truffle project. So if I go inside, and this is what we get. We get two folders, actually three folders, and a JavaScript file. And let's start from the beginning. I'll give you a quick overview. This is very important, you need to know what you're dealing with. So you have this contracts folder. This is where you will create the actual smart contracts, and these are written in Solidity. We already have an example of smart contracts called migration. This basically helps us deploy the smart contracts, as you'll see later. You have this migrations file in which you have JavaScript files that again allow you to deploy the smart contract. Here we have one file, and this deploys the smart contracts we have here. We also have a test folder in which we'll write JavaScript tests. You can write them in Solidity as well, I think, but most of the time, I think pretty much everyone writes them in JavaScript. Also, we have this Truffle config file, and this is a very interesting file because here you will, as you can see, you can just uncomment this, and here we'll configure the blockchain that we're going to deploy to. Here you can configure the local development blockchain, as you can see here. You can also configure public testnets like Robson, etc. So this is a very important file that we're going to use. So let's go ahead and create our first smart contract. Go here in the contracts folder, new file. We're going to call this number.sol, and sol stands for Solidity because we're going to use Solidity. Nobody uses Viper. And I'm going to add this comment here just so the compiler doesn't yell at me later. And this is just, I don't know why they even need this, but okay, it's some license identifier, not really important stuff. We're going to now define the Solidity version with pragma Solidity, and we're going to use the 0.8.2 because I found that this one works for me, and I'll add this sign. I don't know how it's called. This specifies that we're going to use any version is compatible up until the 0.9. So I'm going to save this. You can add a contract using the contract keyword. This is going to be number because we want to keep this consistent with the file name. And here I'm going to specify uint 256. It's going to be public variable called number. Well, this is going to be a very simple smart contract where we just initialize initialize a value to this number, and we also have a function that we can call later when we deploy the smart contracts that will change the number basically. So here I have a constructor, and this is a function that runs when you deploy the contract. And here we're going to have one parameter, which is going to be the new number, or actually the initial number, because this is the initial number we're going to have. Currently, I think the default value is 0. I don't know, not sure. Say number. Let's assign this value, and we'll also have another function which we will call setNumber. And setNumber again will take uint 256, and then this is going to be, let's call this new number. You cannot call this number because we're going to shadow this variable. Let's assign this, let's say number equal to new number. And also another thing, so we're basically done for the smart contract, except we need to add this external keyword, which means basically external is more restrictive than public. We can make this even public. Who cares? Nobody uses this contract. So we'll go into the Truffle config also because we need to change the contract version. As you can see here, it needs to match the smart contract, the version that we defined, which is this one, and currently it doesn't match. So whoops, let's paste this here, and now you can compile your smart contract. And how you can compile them, and by the way, maybe you're confused now, compile them, aren't we going to deploy them? Well, Solidity is a compiled language, I think that's the right term, and you need to compile the Solidity code and get something that's called artifacts. And you can compile them, by the way, with Truffle compile. So let's run this. You can expand, pro tip, you can expand the terminal by just clicking here. I use this all the time. And after you compile the smart contract, you get what it's called contract artifact that we already got here. into the we get created this build folder. Here you have two of these artifacts. These are just JSON file that specify all the that have information about the smart contracts. So here, if I go into the number, I have information about what variable am I storing here, etc. Also, every time the smart contract change, whenever you compile them, of course the artifacts will change. For example, if I add another variable here, the artifact, and I compile this, the artifact will be different. So now that we have developed our super complex smart contracts, let me clear this out. We need to deploy this. So to deploy this, we need to create a migration script by creating new file here into the migration folder, and we'll call this to, because Truffle runs these in order in which you specify. We have one here, two here, and let's call this number.js. And here I'll just copy the code that we have in the initial migration, just paste it here because it's pretty much the same code. So all you need to change is say number here, because we're taking the artifacts from the number contract. Let's call this variable number because that's what makes sense. And here we're exporting this function that deploys the number contract. And also here in the as a second argument is the argument in our constructor that we have. If you remember, you probably do because it was 2 seconds ago. We have this number argument, I forgot the name, argument that we need to pass here, because when we deploy the contract, this constructor gets called. So let's initialize the number to 1. Let's save this, and now we're ready to deploy them. How can you deploy them? Well, you can deploy this by using Truffle migrate, but first I think we need to actually run the development blockchain. And let's go ahead and expand this and run the launch. Is launch the right word? Let's launch the built-in blockchain that Truffle has by saying Truffle develop. This is how it's run. This is how it's done. So Truffle develop. And what this did is it started our local development blockchain, which is built into Truffle. It's called Ganache. And in this blockchain, you already get 10 accounts, as you can see, that you can use. These are their public addresses. These are their private keys. Do not use this in real life with real crypto, because these are only here for testing purposes. And here what I'll do is say Truffle migrate. And also I didn't mention this, which is very important. Also, not only did we run the Truffle blockchain with Truffle develop, but we also run this console. And this Truffle console is going to enable us to run Solidity on these commands and also JavaScript, and it will allow us to interact with the smart contracts when that's already deployed. So let's deploy it first by running Truffle migrate, and then we're going to interact with it using this Truffle console. So as you can see, I have total deployments 2, which means I have deployed two contracts to my blockchain, local blockchain, remember. And also now what I can do is use this Truffle console. As you can see, I'm inside in Truffle develop. And how can I get my smart contract that's developed from the blockchain? So I'm going to say await. I'm copying code because I'm using JavaScript now. We can use await. We're going to say number.deployed, and this is a function. And this deployed allows us to get the contract number when it's deployed. after everything is done. So let's initialize this to C. This is going to be, C stands for contracts. Press enter. We're going to see undefined, this is fine. And now if I just run C, we're going to get this output. Basically this is our contract. How can we know this? Let's get the number variable from the contract. How can we do this? Well, we can say await c.number, and we can actually call a number function on the number variable because it's a public. So Solidity creates public function. It creates a function that you can call with the same name of the variable. So this is, I think, all we need. We need to save this in a variable. I'll call this n. So that's undefined again. If I print this out, you can see we're getting this big number. And what does this mean? This is a big number object. It uses the big number library under the hood because JavaScript cannot handle big numbers, cannot handle big things. So we need to convert this to string like so. Let's print this out, and bam, we got 1, our actual value. And now what we'll do, we have deployed the contract to the local blockchain, but what's more interesting is deploying to a public testnet. What's a public testnet? So a public testnet is basically a blockchain again, but it's not the real thing in terms of, it's not the mainnet, it's not the main Ethereum blockchain, but it's again a test network that you can use to mess around, deploy smart contracts, make mistakes. This blockchain is actually run by real computers all over the world, so it's not local blockchain is what I'm trying to say. So I was mistaken once again. This is the actual faucet you need to use because we're going to deploy to the Robston test public test network, and you just specify your account, your address here, send me some test ether, and you'll get some test ether. So I'm too lazy to code the project, and I'll just walk you through the project I have already created that works. And what you need to do to deploy the contract to this Robston, first you have to install this HD wallet provider using npm. This is a package that we'll use to sign the transaction. I don't know why it's so complicated, but it is what it is. So also we'll need the actual mnemonic, which is the seed phrase of your account to sign the transaction. Also we'll need an Infura endpoint. Infura is basically just a node provider. They will provide the node for us on the Robson network, and you'll get a link to this. I think you can use any other node provider. I use Infura because this is very simple stuff. And also to configure this, you need to go here into this Robston section, uncomment this out. It will be commented like this, uncomment this out. And here into the provider, we don't need to touch any of this. In the provider, you just need to specify your mnemonic, pass the seed phrase, and the Infura endpoint. And then to deploy the contract, now we have configured the network. To deploy the contract, you're going to need to run this command. Basically the same thing we did when we deployed to local blockchain, but now we need to add -- network and Robston. And by the way, this name should be the same as this name that you have in your config file, just so you know. And after you have done this, you can go to after you've run that command, you can go to the Robston test network and look up your account that you've used, and you can see the transaction and the deployment. Another thing I forgot to mention is after you deploy the contract, what you can do is you can interact with it using the Truffle console. But this time when you run the Truffle console, you need to add -- network Robston so you can get connected to the blockchain.